universe is running out of memory, not disk space, actual physical memory. Jacob Bekenstein proved in 1981 that any chunk of reality can only hold a finite number of bits, and once you understand this, you realize heat death isn't passive decay, it's a computation, a final algorithm solving for omega. Today I'm giving you three truths: the Bekenstein Bound, the heat equation of thought, and the statistical nightmare that might make you question your own existence. Stay with me. Most of us imagine the end of everything as a quiet, cold fade. Stars wink out, black holes evaporate, nothing left but thin radiation. That's the story you've been told. But here's what they never told you. The universe isn't just passively cooling down, it's running a program, a cosmic-scale algorithm that's been executing since the Big Bang. And its output: maximum entropy, total disorder, death. Now there's a popular myth that's hijacked this idea. You've probably heard we're living in a computer simulation. Glitches in reality, the Matrix. Even tech billionaires fund scientists to escape it. But here's the raw truth from physics. There is zero evidence. The simulation hypothesis is unfalsifiable philosophy, not science. Max Tegmark and Nick Bostrom both admit it can't be tested. But wait, there's something far more disturbing. Physicists have found that the universe like a computation, not because someone programmed it, but because information is physical. Every electron spin, every photon path, it's a bit. And these bits aren't abstract, they have weight, they generate heat, they're running the ultimate code. Listen, Jacob Bekenstein's 1981 paper dropped a bombshell. The Bekenstein Bound sets an absolute limit on how much information any region of space can hold. And it's tied to the area, not the volume. For the observable universe, that's a hard cap of about 10^120 bits. That's all the bookkeeping reality can ever do, and we're burning through it. So here's a creeping thought. Isn't it strange that the second law of thermodynamics says entropy always increases? It's the only law that cares about past and future. Sean Carroll calls it the arrow of time. But what if entropy increase isn't just a passive slide? What if it's the universe actively erasing its own memory, bit by bit, and generating heat each time it forgets? Now, the Landauer principle confirmed this in 1961. To erase a single bit of information in a physical system, you must release a tiny, specific amount of heat. It's not optional, it's physics law. Think about it. Every time a star fuses atoms, every quantum fluctuation that randomizes a state, the universe is literally warming itself by forgetting. And since the Big Bang, it's been doing a lot of forgetting. This is where black holes become essential. They're the universe's master information processors. Leonard Susskind and Stephen Hawking showed they have entropy, the Bekenstein-Hawking formula, and temperature. A black hole devours organized matter, compresses it, then slowly leaks it back as meaningless thermal radiation. It's erasing structure, maximizing disorder, faster than anything else. Hawking's famous black hole information paradox still haunts physics. When a black hole finally evaporates after 10^100 years, does the information survive? Don Page's page-time calculations hint that after 1067 years, a black hole releases half its quantum data. But the rest, irreversibly scrambled, permanently lost, bit rot on a cosmic scale. But the most mind-shattering implication is the holographic principle. Gerard T. Hooft and Leonard Susskind discovered that all information inside a volume of space, like our 3D universe, can be encoded entirely on its 2D boundary. Like a hologram, if true, our entire reality might be a projection of a computation happening on the edge of the cosmos. We're inside the output. So if the universe is a computation, what's it computing? MIT physicist Seth Lloyd calculated that the universe has performed about 10^120 operations since the Big Bang. Each quantum event is a logic gate, and the only measurable output is the steady, relentless rise of entropy. The universe is solving for its own dissolution, a heat-death equation. Now, here's where the paranoia really sets in. Roger Penrose points out that the Big Bang started with shockingly low entropy, just 1 part in 10^123 of its possible maximum. That's not just improbable, it's insane. It's like a program being compiled with perfectly ordered initial conditions. Someone, or something, set the entropy dial to nearly zero. Why? Before you scream God, physicists have a statistical nightmare called Boltzmann brains. Ludwig Boltzmann realized that if a system fluctuates for long enough, random quantum fluctuations can briefly assemble a conscious observer. A disembodied brain that thinks it's human, memories, feelings, your entire life, just a thermal hiccup, and in a universe approaching heat death. These brains become more common than real minds. The math is cruel. In 2019, Paul Davies calculated that Boltzmann brain fluctuations will far outnumber evolved observers in the far future. So if you apply the Copernican principle, chances are you're not the product of billions of years of evolution. You're a quantum fluctuation. Your children, your loves, your planet, all fabricated memories, gone in a second. Pause.